Yes, thanks a lot, Leo. Can you hear me?
Hear me? Yeah.
Okay, awesome.
Okay.
All right, I'll start. I think Leo prefaced it very well.
I think Leo prefaced it very well.
Oh, I think I hear an echo. I hope it doesn't bother you, but I hear my own voice. But I will start with a short. Let me share my screen. Okay. So I'll start with a brief introduction, maybe just 5-10 minutes, just to so I explain a little bit of the context. I'll go a bit faster through some slides that Leo has already given context about. But yeah, so let's start about the M3. So here we'll look at how it's lowered the barrier for the especially datathons and data scientists working with clinicians, organized by MIT Critical Data. So the opportunity that we saw here in the group at MIT Critical Data is that we of course have the clinical experts who have deep medical knowledge. They also know what questions to formulate in terms of their domain expertise. And they also have the patient care understanding, which is very important. There, on the other hand, we also have data scientists who have, the technical background, whether it be SQL, Python, just digging deeper into the data, navigating it, performing an analysis on it, data pre-processing. And we saw that it was quite sequential in the sense of that the clinical expert may come up with a research question, the data scientist might first present the cohort to the expert. There's a lot of back and forth where some parties are excluded, waiting for the others. So that creates a bit of a productivity bottleneck. And we've also heard a lot of times that in many datathons and in these projects where clinicians and data scientists are involved, that a lot of the time is actually spent on the data extraction, getting the right cohort, looking at which variables we want to look at and so on. And so we were thinking, what if we can combine these strengths, right, between the clinical experts and the data scientists? And we've already talked about Mimic4. Leo prefaced it quite well. There's a lot of data here, very rich. We have more than 360,000 unique patients, a lot of hospital admissions, ICU stays. But the problem is the scale and the complex linkages. So we'll see on the next slide how you have a lot of different modules. You have a lot of different tables and different modules like the hospital folder and the ICU folder, and also linking events between the tables isn't very straightforward, especially if you come to it not knowing too much about Mimic. So we experienced this ourselves, also attending the first few datathons, and we realized that with large language models, this can be, very well improved. So let me just give a brief introduction. I'm pretty sure everyone is familiar with LLMs and at this time, but at the end of the day, they're based on the context, right? So whatever word comes before another word, that's what determines what the LLM will output, right? So at the end, it's statistics, doesn't think like a human as us, even though it might be branded as such, but it can be very helpful, especially if you give it the right context, which is where the context awareness and prompt engineering come into play, which I'll briefly talk about. And so with prompt engineering, very bluntly said, the better your prompts are, the better answers you will get. And so something like, especially if you're using the MCP, which we'll get into, of course, if you just tell it, show me ICU mortality data, then this is quite vague, right? You're hoping that the model will interpret what you mean, or might have to read between the lines. So it's much better to structure your prompt as accurate as you can and as relevant to your use case as possible. So this would be a much better prompt if you would say, you want a 30-day mortality rate for septic shock patients, and you specify the time and also maybe the age group. So we'll look at that at a live example, but that's just something to keep in mind. we also, throughout the time in these datathons, we realized that some kind of best practices that we noticed, as we said, to be specific, to also specify the format that you want based on the analysis you're trying to provide. Also, depending on the audience, right? If you have only clinicians using the tool versus maybe a clinician and a data scientist, you can maybe focus your prompts on the things that will be a common denominator, and so everybody will understand what's happening. Also setting the boundaries and scope, for example, with the cohorts or the timestamps. Again, including as much context or constraints that apply to your use case. And we'll look at different examples, and also things like requesting examples and evidence, perhaps bundled up with like web search with common proprietary models or even open source models. You can also kind of let it verify from external sources as well, not only relying on Mimic. So yeah, and this kind of ties to also the ambiguous language that we talked about, and also what Leo mentioned, that of course this lowers the barrier, but this doesn't mean that you can just say, hey, write me a paper about sepsis and hope that this will be 100% accurate. It's best to break it down step by step and have some kind of validations both from the clinicians and the data scientists. So we're not trying to get rid of one or the other, but rather try to make each other more productive and lower the barrier for such projects and creating even more research in this community. So this is what we proposed, the M3, which stands for Mimic, the MCP, which is the Model Context Protocol, which I'll define in a second, and also models in the sense that you can use this with different models. You can use this with, for example, Claude models, OpenAI models, and even if you have privacy concerns, you can use open source models, which I'll also demonstrate. So things you can download and it will run locally, and so your data never leaves and your analysis never leaves your hardware. So let's start with the problem. So as we said, Mimic is quite hard to manually navigate. In the datathons, after attending a few, both nationally in the US and internationally, we've noticed that a lot of the time, especially in the first day, spent on figuring out the data. So this is where the MCP for these tabular EHR data can be very helpful. And you can think of it as sort of the USB between the models and the external data sources. So MCP allows the query and the translation and the execution of what you want in natural language, and it will also present you the answers of the SQL queries, the executions, and it will also build some nice insights to get a quick exploratory data analysis for your use case. So this is why we think this matters for healthcare, because this allows you to interact with such a rich database as Mimic. You can also see the exact queries that the MCP is producing. And this, of course, can be verified by a data scientist also in more complex cases. And this sort of provides the MCP as standardized interface for LLMs. So you can also use other tools, as I mentioned, like web search in conjunction with the M3. So this is the architecture. We won't go into a lot of detail, but essentially I'll show here an MCP client. So this can be like Cloud Desktop or LM Studio. I will show both. And through the MCP protocol, we also have some security and validation layers. So you can't write to the database, you're only reading from it. And so there are mechanisms that have been implemented to make sure this is safe and secure. And also some tools with the MCP server that allow the model that you're using to get even more context about the tools it has and how it can use those tools to effectively query the data. So we'll see that in the live demonstration as well. And here we also tested it first with the demo data set that is meant for demonstration purposes. But also if you want to do this with the full production scale, full Mimic complete data set, you can do this also through BigQuery, for example, where it's hosted. So yeah, this is the preprint that you can find about M3. You can also scan the QR code to see the GitHub repo. I'll show it in a bit. And it's got quite a lot of downloads, more than 1,000 in the first week. We've also tested it on an EHR SQL benchmark, which I'll also take some examples from. to give you a feeling of how we tested it. And from preliminary evaluations, it was also quite accurate. And the way we evaluated the accuracy was there are some data sets formed by SQL experts where they define the ground truth. And so we compared what the model outputted and validated it against this ground truth. So I'll show that in the next slide. Okay, here I have a video, but I'll do a live demonstration because I think that's better. And yeah, you can feel free to interrupt me. I can also maybe do questions that you can propose. So let me show you first the GitHub page of M3. So here it's on GitHub. There's also an about section that briefly describes what it's about. There's a website also for first-time users. So if you've never worked with Mimic or you're just trying out the tool, you can scroll down. You can find the preprint as well as the videos, because we think that it's much easier to follow a video than like 5 pages of text. So even if you don't have your PhysioNet credentials and you don't know how to get started, everything is outlined here and it's shown to you step by step. You can pause the video, go through the credentialing. You can look at how to install this tool, and then you can see how to use it both with the demo dataset and also the BigQuery dataset, so with the full Mimic dataset. So there's a lot of, you can see the videos are a few minutes long, so I'm sure that these will be very helpful for first-time users. And as you can see, we also have like open issues and pull requests. We're continuously trying to improve this through community support. Yeah, here's also a description on how to get started with it. I won't get into the nitty-gritty details of the first installation and waste time here, but I'll show you what a live demo looks like. So it's quite simple. If you're using things like Claude Desktop, I'm pretty sure most of you have used an LLM before, like ChatGPT, Claude Desktop. I'll show it both with Claude and with LM Studio, which is another MCP client. And here I'm using an open source model. So let's start with Claude Desktop. It's very simple to set up. So all you have to do is in the settings, when this opens, is you have to paste in a block of code that's mentioned in the GitHub. I think now due to time's sake, I will skip it for now, but essentially, okay, now it's opened. Essentially here in the developer setting, you just have to make sure that the M3 is running. And so you can see here in the settings, you have the M3 enabled. You also see what tools it has, like getting the database schema to allow the models to understand the structure of the database and also get more information about the tables. So we can start off very simple. You can ask questions like how many patients are in Mimic 4, right? And you will see the model not only relies on its knowledge that it's been trained on, but it will use this M3 tool to figure out more context about what I'm trying to get at. So as you can see, it first looks at the database schema. So it realizes, okay, we have this and this table, for example, like in the hospital module, an ICD diagnosis table, and so on and so forth. You can see how big the Mimic database is. And then it ultimately executes a query on your behalf, such as selecting the count. So again, you don't have to know the exact syntax for this, but if you have a data scientist, especially as the complexity grows, you can easily verify by sort of trailing the request and seeing what the model has executed for you. And then you get an answer of, okay, the Mimic core has, for example, over 360,000 unique patients. So this is obviously a very brief example. We can also look at here in the GitHub repo. We have a few here in the benchmark section, a few of the questions that we took from an NAACL EHR SQL dataset, which was in an NLP workshop. You can see some queries, like, for example, this is a bit more complicated. You're trying to find the PLT count last measured between the first hospital visit compared to the first value on the first hospital visit for a specific patient. So this involves also calculations. You have to find the specific patients, and you have temporal measurements that you're trying to compare. So this is not as basic as how many patients are in the database. You can see we tested it on Claude. You have here, for example, the link to also look at the chat. Here we presented the model answer, and also there is a ground truth from the data set that we use, which is 14. That's the difference of the PLT counts between the measurements. And you also have like a golden truth SQL query from the data set, and we can gladly test this. I will test this on the demo data set because that's what the data set was designed for. Just one slight difference here, the answer might not be 14, and maybe this patient won't exist because in this data set, the CHR SQL data set, they modified a little bit of the table, so it might not be exactly the same answer. But this will just goes to show you here, I'm using an open source model. So again, if you have worries about using proprietary models like Cloud Desktop, etc., you can use these open source models to sort of bypass this privacy concern. And you can see that here it used one of the tools to get the lab results of a specific patient. This is the demo data set, obviously, so I'm not showing enough, I'm not showing sensitive information. But again, this was a little bit different, so the answer won't be exactly the same, but from what we've tested, it was more than 90% accurate on with an open source model and a proprietary model. So for EDA, exploratory data analysis, and lowering the technical barrier, it has been great, but of course, more evaluations will continue also from our group to determine the limitations and also the sort of future next steps for this project. But we're very excited about this, and yeah, I'll stop right here to see if you have any questions. And yeah, I can gladly also show more things if there was any confusion. I hope I wasn't going too fast. I don't know if someone's speaking, but I can't hear anything.
Repeat the question for you. You hear it or not? I will answer for you need a data science physics. I don't think that was purpose of these is for us to learn from each other. And I think I'm very much against people doing projects on their own because I think you don't learn as much as compared to surround yourself with people who see the world different. So in our paper, we actually emphasize that in the introduction. This is not a reason for clinicians to think that they will be able to build AI tools without the help of other people working up with the technology. So for the office hours and for every use, I think, of MCP, we would truly promote this interaction between clinicians who understand the domain and the data scientists who understand the data and the tools, but do not have a good understanding of the context of the data.
I have a question. So, how is the latency of the system? For instance, if I want to deploy it in a hospital, how big is the model that you're running? So, how much do you need? And for instance, the instruction you just showed using AWS cloud or using private GPU.
Yeah, that's a very good question. So I hear an echo again. I hope it's not disturbing for you. But yeah, that's a very good question. So in terms of, as I mentioned, there's a SQL demo database that we're using. So this one is downloaded to your computer, and everything happens locally. So all these tool calls are happening just on your computer. There's no network latency. But if you're using the complete data set right now, we have a connector with BigQuery, where MetaMimic database is also hosted. So there is the latency of the API with the Google BigQuery, but we've also developed, as Leo mentioned, for like the Korea Datathon, the KM3, they had it on a private Postgres database. So there, it was a different connector for a private database. And it also worked quite well. It was hosted for more than 50 to 100 participants and mentors. And I would say it worked just like the usual proprietary LLM or like ChatGPT. Of course, the latency will also depend on how many tool calls the model will use during that specific chat. But yeah, this is a little bit variable, and this is actually quite interesting. It will depend on the complexity and also if you're using it, as you said, like in-house, or are you calling a database that's on your local network, or are you calling a database that's hosted somewhere else? So I hope that answers the question.
Add a comment. Yesterday I was trying with like a complex query, and even if it takes like 5-6 minutes to run through all the process, you can leave it running when you have all the logs, so you can go review what happened and interact with every step. It takes a long time to process it. It's something that can run on the background. Then you just evaluate the proposal. If you don't like it, you iterate again. But it's still way faster than wait.
Thank you, Rafi. This was an excellent presentation, and also thank you, Leo, for your words at the beginning. I think that this is a really terrific project, one that we're very supportive of and look to engage with. I had a question just around the notion to try and make this as easy as possible for clinicians to access, and the use of sort of free text and language models that may be used. Have you noted any variance between different types of input? Meaning, if you were to put the same, free text into different sources, have you noticed any variance in the output based on which model has been utilized?
Yeah, that's an excellent question. Actually, we have. I'm gonna mute myself just because I have a really loud echo. But as soon as I stop talking, I'll unmute. But I won't hear you for a while. So I'll share my screen. There's in the benchmark data set that we use. Actually, as you can see, we used here Cloud Sonnet, a proprietary model, and an open source model, GPT says 20 billion. And we have at the last column an incorrect note. So I believe 7 questions that GPT says got wrong and 6 that Cloud Sonnet got wrong. There was a bit of overlap in what they got wrong, but there were also some unique, let's say, incorrect answers. That we also described in the paper, but to give you sort of a summary, some of it has been linked to ambiguity, because some questions, for example, say, what is the difference of this measurement to the last measurement in the hospital, or to the last stay? And for example, one model would take the end timestamp of the last stay, another model would take the first timestamp. So here it's a little bit of an ambiguity interpretation problem. So definitely this would be combated with things like prompt engineering. But as you also correctly said, this will be highly individual based on the model you're using, the type of sort of mistakes that can occur. Or we've noticed that smaller models sometimes jump into using tools before the expected workflow. So we would ideally like them to look at the schema, look at the tables, and then execute the query. But some smaller models, in the range of maybe 1 billion, they would try to jump into the query execution without looking at the schema, which we found that, of course, this didn't perform as well. But with models around 20 billion and above, especially GPT OSS, that's quite good at tool calling, this was actually quite well. We were surprised how good it was compared to Cloud Sonnet 4, which is, it's not official because the parameters are not officially disclosed, but at least 3 to 10 times smaller, and it performed just as well. So at the end of the day, if you have an open source model that's good at tool calling, that should do the job fine. And regarding the ambiguity problems, that's a matter of breaking down the complexity and also making clear non-ambiguous statements. As I said, when you mentioned the last fade, you mean the exit time or the entry time? So things of that nature. But it's a very good question that, of course, needs to be discussed, which we also mentioned in the discussion. So thanks for asking. I'll unmute.